In this video, I'm going to find the conditions for the constants a, b, c, and d that make the ordinary differential equation ax plus by dx plus cx plus dy is equals to 0 exact. So we want the values for the a, the b, the c, and the d that make that differential equation exact. A differential equation m of xy dx plus n of xy dy equals to 0 is exact if the partial derivative of m with respect to y is equals to the partial derivative of n with respect to x. So if I look at the coefficient of dx here, we are having an m of xy. The coefficient of dx in the given equation is ax plus by. So by comparison there, we see that m of xy is equals to ax plus by. I now move on to look at the coefficient of dy. The coefficient of dy here is n of xy. The coefficient of dy in the given equation there is cx plus dy. By comparison, we see that n of xy is equals to cx plus dy. So we now have our m and our n. I will now go on and evaluate the partial derivative of m with respect to y. For the partial derivative of m with respect to y, we are looking at the ax plus by there. Differentiate it with respect to y, treating x as if it's a constant. And the result that we'll get there is the partial derivative of m with respect to y is equals to b. Now move on to evaluating the partial derivative of n with respect to x. We are looking at the cx plus dy there, differentiated with respect to x, treating y as if it's a constant. So we would have the partial derivative of n with respect to x is equals to c. So what we are having there are those two, the partial derivative of m with respect to y, the partial derivative of n with respect to x. For this differential equation to be exact, these two partial derivatives must be equal. So what we'll be having there is that this b here and this c here must be equal. So what we are having there is, for the differential equation to be exact, b must be equal to c. A and d can take any values, but as long as b is equal to c, then we are guaranteed that the differential equation is exact.